Over 12 years ago, North Central High School expanded its science program to include authentic research. Today, the Institute of Science and Technology at North Central is sending top-notch high school graduates to high-level university programs. Welcome to School Talk. I'm Taryn Roloff, and joining me are North Central teacher Randy James, WSU freshman Nick Negretti, and another WSU freshman Joe Lawhead, and Superintendent of Spokane Public Schools, Dr. Nancy Stowell.
Hi, Darren.
Hello, and welcome to you, and especially to you young men for joining us today and driving up from WSU to be with us.
Thanks for having us.
We'll explain why you're here. In fact, Dr. Stowell, maybe you can explain to our viewers how this institute at North Central is really affecting all of our district in the development of science and technology and engineering and math.
Well, first of all, I think this Institute of Science and Technology does such a superb job of ensuring that our students are college and career ready. When you get into college, and you explained this today at our Community Leaders Breakfast, you have the skills you need to be successful as college freshmen, and we know that many students who enter college don't finish that freshman year because they're not adequately prepared. So certainly this institute does that. And then on top of that, it really provides people, our students as they're young, that look at science careers. And when I visited you all last spring, everybody was saying, well, yeah, I'm going into science. Well, yeah, I'm going into, well, like a ridiculous question, Dr. Stowell, that you would ask us what we were going into. So it's a great opportunity, and we want to expand that program under Randy James's leadership and make that opportunity available to more children, students in our district. So,
well, Randy, let's start with you. Tell us a little bit about the Institute.
The Institute actually is, it has been around for quite a while. It's got 3 levels of classes. There's a freshman class called Biomedical Technology. There are a few sophomores in there. There is a junior senior class called Biological Solutions, and then there's a capstone called Genomic Research. And the freshman course does introductory biotechnology type stuff that what we found is quite like what kids do as juniors in college. And then Biological Solutions is actually authentic research, but more directed by me. And then Genomic Research, which these guys mastered, is true authentic research that the students are flat out, they're in charge. They do all of the work, publish DNA sequence, publish papers, present papers at conferences. We even had students at a national conference last year presenting their papers. So it's a pretty exciting lab. It's a very busy lab.
In fact, we have some video from last year, I believe, that we'll share with our viewers so that they can see kind of what we're talking about. Go ahead, which class can you tell? Is this
this is a biomedical technology class, and I think they were learning how to use pipettes in that, and so I think, yes, and setting up a lab, and they've got their lab coats, doing a little bit of whiteboarding, and if I can see the whiteboard, I'll know exactly what they're doing, but I'm not really sure where they're going.
And you two were probably in that video from last year, or maybe you had already advanced to the next level. But in any case, you're here today because you are such successful graduates of the North Central program. And let's hear a little bit about what you learned there at the Institute.
Well, at the Institute, you pretty much learn the basic knowledge that you need to do to go into a lab and just start working and do it effectively and actually be an asset to a lab. And it's even more apparent now in college, and I think Nick will agree with, if I could walk into a lab anywhere on that campus and immediately put my skills to practice. And it's like that simple of a transition that the IST allows you to do into college. Is you go straight into a lab and you can say, yeah, I've done this, I know what it is, let's go, let's do science.
Well, and this isn't just like a lab like you would imagine for your biology class, but it's a lab like that does research, a research laboratory. They all use the basic techniques that we learned with pipetting skills and how to work cleanly in a biology lab.
And procedures that are done in the IST from freshman year through junior and senior year are procedures that are done globally. They aren't just something that we've designed just for our lab. These are actual procedures that are done worldwide in a variety of labs. And so it's really cool to say, yeah, I'm doing real science because it's global science, and science has to be global so you can talk to other people and get your message out there that says, yeah, we're doing this, we're doing what you guys are doing, it's really cool.
Talk to us about your research, because it really is cool.
So basically what our goal was, and we didn't realize at first that this project was going to be so big.
Never do.
Exactly. What we were trying to do is identify the kind of bacteria that live inside the gut of a honeybee. And we were doing this by pulling out the DNA inside of these bacteria, the little bits of DNA that identify them, amplifying them, cloning them into bacteria so the bacteria would make copies for us that would allow us to look at what the sequence was, and from that we could determine which bacteria that we had found.
And you're doing this in high school as
Certainly.
seniors.
Yes,
Yes.
We were working on it, yeah. It was,
Wow.
I think the one thing that we didn't expect about the entire thing was how much work it actually would have been. I went in without any idea about something, like I thought that the project would be pretty straightforward, because
that's what high school's been, right? You didn't do a project.
and we had been doing stuff like that for 4 years in the IST, but being actually fully self-directed for an entire year was an eye-opening experience. I am a completely changed person because of it. It was just such a big deal just to be let open and say, go solve a problem.
And the problem was, in this case?
We started out looking for causes of colony collapse disorder, CCD, which really devastated bee populations in 2007, 2008, and that's when it kind of got the most news coverage. And we decided that we were going to try and shed any kind of light on that, and little did we know that's also a really big thing to bite off, but it was a really cool experience.
So I imagine you spent more hours doing that work than you had imagined, or that you'd done on any other projects.
Oh my goodness, we showed up in the morning at 6:30 almost every day for several months, and we stayed until about 5:30 in the evening, a lot of the time, so we could have more time to work. And it was a lot of fun to be able to put that much work into a project that you can take ownership of and direct where it's going to go.
They probably put in well over 500, maybe even close to 600 hours beyond the normal school day in the laboratory. And that's not counting the dozens and dozens of authentic research articles they read to find their basis, and then taking the problem home, and they'd show up with all these calculations, and then they convert them into whiteboard calculations so they could talk through them together, and that. It was remarkable. It was a really great experience for us.
And how unique is that, since you've been teaching for a long time?
You know, we're always trying to get kids to invest. It's challenging to remove yourself and not micromanage in a laboratory. And if you micromanage, then you're not valuing the kids' minds. They have these amazing minds. And so if you back away and let them problem solve, and we call them successful failures. So let them have successful failures, and let them fail and fail and fail, and learn what persistence looks like. Then it complements their mind every time, because they solve the problem and they solve the issue. And that's what we want kids to be able to do, is walk away and not have to have somebody manage them. They can make choices, and some of the choices are extremely time consuming, as they discovered. They go down a pathway and go, you know, I wish we'd gone this other pathway, but really good experiences. So we embrace successful failure, and tremendous learning comes from that.
So let's hear about what you're doing at WSU and your plans there.
So we are actually working towards getting into a lab actually by second semester of our freshman year, and working in a lab and doing research there. And that's pretty much the plan so far. And we're also trying to get into the STARS program, which is an accelerated PhD program from WSU. And it's kind of like squishing 8 years of schooling into 7.
Squishing,
yeah.
That's a good scientific term.
And oozing, but yes. And it really is about cramming all of your work and doing it efficiently and correctly so you can get out and start doing world-solving problems in 7 years and doing cool research. So it's a really cool program.
So how do you go about achieving that?
The most important part is to make the right connections. You have to know what you want to do so you can talk to the right people and convince them that you're worth their attention. So what we do is weekly we'll talk to Dr. Bill Davis about some seminars that we attend. So we'll go attend the graduate student seminars to learn what's going on in the labs at WSU and learn what kind of research happens. And we talk about procedures that maybe we're not familiar with, or discuss if we agree with how they interpreted their data. And that's going to allow us to get a little bit more ahead so that we can step into the labs that we've heard about and be productive.
Are there any other students from across the state or from across the nation that are like you as freshmen asking for this opportunity?
Out of the gigantic freshman class that WSU has, there's 6 of us.
And two of you are from North Central.
Yeah.
That is very exciting.
Pretty cool.
Yeah.
That is very cool.
Yeah.
And you know, Randy, you're very modest, but I know some science people, and they tell me that your program is really remarkable, and it isn't really replicated probably anywhere in the state of Washington, and not very many places nationally.
Yeah, I don't know of very many places. I don't know of any place in Washington State, and I don't know of any place actually in the nation that actually has multiple levels where you've removed filters. So, you know, as our freshman class, there is no filter. We try to get as many kids in there as possible, and again, compliment their minds and give them a chance to invest and dream and plant seeds early. So it is pretty unique. And yeah, it's a wonderful place to be, busy place.
I know that you're expecting that these gentlemen will come back with Nobel Prizes in the future.
I do, I fully believe that there will be a Nobel Prize coming out of the lab. And it's not being, if you advertise that you deserve a Nobel Prize, you'll never get one.
Oh.
Never.
Well, then we better hush up.
No, but you can actually say you've planted the seeds for a Nobel Prize. And I fully believe, why not?
Right.
They come from all other places. Why not from North Central High School and Spokane Public Schools? So someday it'll be in the front page of the Spokane Review saying Nobel Prize winner. And I fully believe it. It's going to happen.
So you happen to have some connection to WSU currently.
I do.
Yeah, where you were telling us a story about how your junior?
My son is a junior. He's a molecular bioscience major, biochemistry major, and he's taking a biotechnology class. And many of the labs that he's doing now are the very same ones that my freshmen are doing. And so he had to wait till he was a junior in college to be able to do those various labs, and then my freshmen are doing. So my freshmen are rock stars in the case. And the goal is to make not all the equipment and all the procedures to be this ooh, ah. It's what they tell you. It's the tool. You want them to recognize that the tools are just tools. They're not something special, but what tells you can be very, very special. So if you introduce them really early with really complex labs that last days, if not weeks, then they're not just enamored by the lab. It's that, oh, look what we just discovered, the experience and what they can learn from doing it. And that gets them really ready to go off to college and not have the wow factor. The wow factor is what you learn.
What are some of the research projects going on right now?
We still have bees. We're actually looking at the effect of herbicides and pesticides on various fields, on how it's affecting the flora in the gut of the honeybee. So if hive collapse might be triggered by trace elements of this pesticide or this pesticide. So we're looking at that. So we're continuing the honeybee study. We have a mule deer, white-tailed deer study where we're actually DNA fingerprinting and looking at genetic diversity of herds from the northern part of the state clear to the southern part of the state, and trying to find out if there's gene flow between them because they've gone through a bottleneck. Starting in January, we'll actually go out and trap whitetails. We'll actually ultrasound them in the field to see if they're carrying a single fetus or double, if they're carrying twins. And then we'll actually, just like they do ultrasounds that doctors do to tell you when your term is, we'll actually measure specific bones, and we'll be able to tell if during their first heat, second heat, or third heat, when they actually got pregnant.
Wow.
We'll actually DNA fingerprint the does, DNA fingerprint the fawns that are near them, and also then the bucks, and we'll be able to find out who's breeding who from that herd also. We have a minnow study, we have our bison study, and we're looking at Paleolithic and Neolithic bison and trying to find out what bison looked like before they were all hunted down. We have a human ALU study, and we're looking at jumping genes inside of humans. So it's a really busy place. It's a wonderful place. Kids doing some amazing research. Lots of successful failures, especially recently, but also some pretty aha moments. In fact, when I left the lab to come here, we have some kids camping out there, and they probably won't leave till 6. They have a reaction that's happening, and so you just put it on ice. They go, no, we want this ready for Monday, and then we have probably over a dozen of them will show up on Saturday morning, and they're going to put about 5 hours on Saturday, trying to get some lab work in that they can't get in during the week.
We talk about students taking responsibility for their learning, and I really haven't seen any program like this. where the students really do own. You young men owned your learning in that lab, and as a result of that, you have incredible futures ahead of you. So it's pretty amazing.
Yeah.
And we just have a few seconds left, but we do want to take the opportunity to hear from both of you again if there's something you'd like to add.
Your
And,
last- yeah, your last-
chance here.
Go. I want to say that this is probably the most important thing that I learned in high school was the true value of hard work, and it's not something you can exactly learn in a class where you're kind of given what to learn, which isn't bad, but when given the chance to kind of explore, it's really easy just to pick up on things that you would have never imagined.
Yeah, and it's just the unique opportunity of a class where it's so open-ended that you really are given the power to say, you get to pick what you learn. You have to put the work in, you have to do it, but the things you can learn are so exponentially larger than something in a structured class where you do things by the book, and you can pick those up, but when it's so open-ended, you learn so many more things so more clearly because you're the one figuring them out, and it's really cool.
What do you both want to?
Yeah, no, I was just going to say they're
Yeah.
remarkable
Yeah.
young scientists.
Yeah. What do you want to do when you're done with?
We both have similar aspirations. We're both microbiology majors, and the ultimate goal is to get a PhD and work in a research laboratory, most likely at a university, but I suspect there's going to be multiple problems out there that don't even exist today that we'll find years from now.
Yeah, the science is always dynamic, and there's never really one catch-all answer, and so there's always new things developing, and I'm really excited to see what happens and where I can go after college, hopefully with a PhD, and just jump in and start solving problems that are new and exciting and things that haven't been looked at before.
Nice, yeah.
Pretty cool.
Very good. Well, thank you for joining us today.
Thank you.
And Randy, to you as well.
Thank you.
And thank you for joining us on this edition of School Talk.